Good afternoon, everyone. So I'm the speaker who was tasked with the most impossible task of them all, and is to entertain you right after lunch. But it's a pleasure to be here. So our topic for the talk for today is how context and data fidelity are king. And it's about the case for vertical cybersecurity solutions in the OT industry. So it's not a coincidence that I'm talking about this subject. I'm the co-founder of Silos, we're a company focused on rail cybersecurity. When we founded the company in 2017, one thing that we've noted is the rail environment is different. And there are a lot of causes of why it's different, and I'm going to cover some of them today as part of a general case. But if we look at it from a broader perspective, I think a good way to look at it is just as this graphic that you see behind me. There is an evolution in the cybersecurity environment. So when security just started, it was mainly for IT. At some point, folks in the OT environment understood that OT is different. And the typical solutions that were applied to IT environment, this hammer that for which the entire world is a nail, are not really suited to the OT environment. And then another class of solution has emerged, and a great conference has emerged, which is S4, and it's the class of OT security solutions. So in OT security solutions, what we're seeing is that you have typically solutions that are basically not IT security solutions, and that they're used to protect different operational technologies, let's say as a broader term. And one thing that we're seeing is that having a security solution that is basically tailored to protect so many industries is fairly impossible. So the common denominator of those industries is quite low. And the idea is that those solutions doesn't necessarily make the cut in many of those industries. In some industries they are, in some industries they're not. And the natural step of evolution afterwards is getting to those verticalized security solutions. So those solutions that will bridge the gap for the industries that still have this gap from the generic OT security solutions. So for example, our company is protecting OT security within the rail environment. So you can say that we are OT security vendor focused on rail, or rail vendor focused on OT security. Actually, we wanted to give it a fancy name, which is like rail OT, but then we understood that the spelling is rot, and doesn't really work. So we just call it like with the less fancy name of rail technologies. But generally speaking, we see these trends also happening in other industries. And today we're going to try to analyze what are the causes for this trend and what can fall short when implementing a generic OT security solution in specific industry environments. So what are those criteria that define whether an industry is suited for a specific solution or not? So we try to kind of like build up those criteria and understand what can be unique about an industry. So one topic is like functional applications. That's the basic one. So what are the core business applications that power the industry? In rail, it's moving trains. In hospitals, is saving people's lives. But there are lots of like different topics or different business processes that might be unique per industry. And understanding those business processes are important because these are also the business processes that hackers will potentially try to disrupt. The other thing is device profiles. So not all industries were born the same. I assume that some people who work in particular industries can give us some terms or types of devices that none of us have heard before. That's what you get when you delve into a particular industry. And understanding those profiles is even more complicated than understanding protocols because profiles sit on top of them. These are the particular engineering nuances of different applications or different systems. The third is suppliers. So some suppliers only operate in particular environments and do not operate in other environments. And therefore, to protect their equipment, it means that you need to get the understanding of how this equipment works. It might be a particular operating system, it might be a particular protocol, it might be particular applications running on top of the protocol. But understanding how it works is quite important. The fourth is regulations or standards or requirements. It really depends on the industry. There are different regulations for safety or for operations. Regulations might be also cybersecurity specific and might be also applied in a particular industry. Like the TSA has sets of regulations for different industries. Some of them are similar, some of them are not. And we can see those regulations happening all around the world. And last is protocols. So we all know protocols. We all know what's the meaning of protocols. But actually, protocols can be a bit deceiving because the understanding of a protocol might vary between just knowing that it's there to actually understanding what is the meaning of every bit in every configuration. And this gap is quite wide. In my opinion, getting a good understanding of how protocols work in an environment requires you to actually understand the bits and the pieces of the application layer and not just getting to the level of understanding whether the protocol is there or not. So the question is, has any of those happened to you when trying to implement security solutions in particular industries? Because I definitely saw it a lot in different industries. So first, you try to build an automated asset inventory, but you ended up with having a glorified spreadsheet. And by glorified spreadsheet, it means mainly you can always get some inventory. You can always say that an IP address is over there. But the question if you can get more than that, if you can get the understanding of what really the asset is. And we'll try to make the claim that knowing what the asset is actually crucial to many different business applications afterwards. Second is that you can have a lot of things that look like security alerts, but actually they're by design. And knowing what is by design is actually requires you to understand how the particular equipment, particular system is supposed to work. So you could really understand whether something that you can classify as a security alert is supposed to be here initially. So for example, one of the things that we did when we were speaking with railway people initially was to talk about the fact that it's quite easy to make trains stop. But making trains stop is not really a big challenge because by design, there are a lot of functions that make trains stop. And they're not necessarily treated as a similar threat, like the threat to a safety system, the threat to making two trains collide or something similar to that. And the third topic that might have happened to you is having a solution that looks really good on paper, but effectively cannot be really implemented in the environment because of different business constraints, because of different operational constraints. And I think that the main challenge between having a generic system applied in different industries versus having an industry-specific system is the fact that whatever is not in the system should be implemented manually by whoever is the customer of the system. It means that the system doesn't have to be industry-specific, but eventually someone needs to bridge the gap. And the reality is whoever bridges the gap is probably the customer and it's probably going to result in a higher total cost of ownership when implementing such a system. So things that look good on paper might not look so good in reality and might require a lot of time from your engineers. So let's break down what are those components that can differ between industries. So first, let's start with a topic that all of us know and are familiar with, which is asset discovery and what is good enough, really. So you could say that just discovering operating systems or things that you can discover in the IT environment or even types of assets might be sufficient in many of your use cases. You can build an inventory, and it will be an inventory. It's really hard to measure how good inventory looks like. It really depends on your business objective. But one thing we're going to try to claim is having a business function and understanding it is actually much more important than just getting a pure inventory of assets without understanding what they mean. And I cannot have a real presentation without covering Rail a little bit, so let's get you 1 minute about Rail system and try to talk about the different nuances of the Rail environment. So what you see behind me is basically a graphic of the subsystems that are inside the Rail environment. So it's quite a complicated environment. I'm not sure how many of you are familiar with it. But it's similar to the Purdue model, you can say. It starts from above with the operation and control center. That's where you see the dispatchers that operate trains and so on. It goes down to the interlocking level. So these are some of the key signaling components, train control components. There are a lot of wireless communication that is responsible for train control. If you go even lower, you get to the level of the field elements. These are the switches, the railroad switches, the light signals, and the train detection systems that are on the tracks and are responsible for detecting the different trains. If you go even lower, you get to the trains. The trains, as you can see, have quite a lot of systems in them. And those systems are all implemented on board. Some of them are communicating with the wayside environment, and they're quite unique in nature. So those systems actually vary and you can think about it like having a power supply system for electric trains, for example. You have telecommunication systems, so some railway operator actually operate a full-fledged like GSM, or unfortunately GSM actually network. It's like second generation of mobile communications. You have trains that are moving, and you have signaling systems that are responsible to control them. And there are a lot of subsystems there. You can also have a lot of like building management systems on the station side, and so many more. And one thing that you can see here is that over 70% of the types of the systems, and that's, by the way, an industry standard. It's called TS 50701. It's based on IEC 62443, and it's just for rail. It's a European standard. So one thing that you can note here is that over 70% of the types in those systems are rail-specific. So like you can have a type like an ATP system, which is automatic train protection. It's responsible for stopping trains like positive train control. And let's say you try to implement something in that environment that is not really coming from rail, like just something generic. You eventually are going to be capped at identifying only 30% of the types. And that's assuming that the rest of what you're doing that is generic actually works perfectly. You're not going to be able to get more than that just because of the nature of the industry. And the same probably applies to other industries like maritime or healthcare or aviation. You can see that a lot, that you're quite limited with the generic knowledge about the world, just as the IT people were limited when they approached the OT environment because the OT protocols were so different. And just let's zoom in on this electrical substation system from the slide. So as I mentioned, like rails are electrified, and they have this notion of like having a power distribution system within them. And one interesting thing about it is that those systems are not really considered safety critical. So even if they stop, the trains just stop. And I already told you what happens when trains stop. It's sad, but it's not like the biggest threat. The biggest threat is actually trains that have safety train accidents that have safety consequences. And even if you just look at the notion of like understanding what's important here, understanding what like across all those systems is most important is something that requires having an industry knowledge. So why getting like into granular level is such a must? So if you think about it, the idea is that you can start by identifying an asset, which is cool. Then you would like to understand what's the subsystem or the system that it's part of. After you understand that, you can understand the business function. When you prioritize the different business functions, you get to impact. And that's where you actually get to risk. And all of it is really the context of the system. So unless you're able to get to this level of a business function, and from that to understand the impact of an attack on particular assets, you don't really have a good context, and you cannot really measure the risk effectively. So let's move to another topic that all of us are familiar with, which is more like the alerts or the threat detection aspect of the world, and how do you really measure that? So first, I think that the most important thing about it is actually differentiating the normal from malicious. So you can have baselines and so on, but understanding what's a normal alert requires many times understanding really the application. The second, just as before, just as understanding the subsystems and the assets, it's important to have the ability to prioritize those alerts. To have the ability to prioritize and understand whether now I'm having an alert on a particular asset, which is safety critical component, so I should really worry about it, or it's on a train, or it's on some signaling system. And if I don't know that, I can treat all of them as the same. So if I don't know what are the important systems, I can really assume that all of them are the same, and it's quite hard to act upon them. And the third one is having enough context for response. So it's not just enough to have great detection mechanism without having proper response planning or having proper context to have a response process. You cannot really complete your own threat detection program. And that kind of like the thing that you might not think about originally, but that's what's going to spare you a lot of time afterwards. So if we look based on the NIST 861 framework of what's the incident response process, and we go into the detection and analysis phase, for example. So understanding what's normal and what's not, that should be a big piece of analyzing that. Because in reality, a lot of like those detection mechanisms generate false positives, and being able to have granular understanding of what's false positive and what's not, that's key. Second is understanding how to prioritize on how important is an event. Getting a priority that is based on the business function context, also important. Third, which we found out is super relevant, is actually understanding if you can have a correlation with business systems. So you might have a system already on the operations side that generates different types of alarms. If you find out that alarms are related to alerts that you have, it can give you a lot of context on how to investigate it, and your SOC people can really start from a point of view that is not so trivial. So just having an alert with the pure context of a detection solution is not necessarily enough. Having an understanding of what's the business process and whether something is now happening in terms of trial or maintenance activities, that's something that can really accelerate your investigation process later on. After you get to the phase that you understand what's going on, you want to get to the containment, eradication, and recovery processes. And there, again, you need to have a good understanding of what is allowed or not allowed to do with some assets. Are you allowed to patch them? Are you allowed to block them? Can you just put mitigation controls in front of them? Otherwise, it's not going to fly. And there's also what's allowed to do in the environment. Maybe you cannot really do anything because the environment is part of a safety critical system and you are not really aware of it. You have the financial implication of different alerts. You don't really know what it's going to be unless you're familiar really good with the business and what's the cost of the assets as well as what's the cost of stopping the system for a while. And the complementary to that is, of course, the safety implication. So there are a lot of things you cannot do in various industries because of safety constraints, and that's something important to note. And another topic that I would like to cover here is regulation. And regulation, it has twofold role. One of it is what are the constraints that an environment has, and what are you allowed or not allowed to do in those environments? And that's something that's important to know because it really forces you to implement only specific types of solutions in those environments. And the second is how those solutions can empower really compliance with the different regulations of a particular industry. And just as an example, we can see here a bunch of regulations in the rail, as well as automotive and maritime domains that are really specific to those industries. And by being effective in protecting those industries, you actually need to know really well what those regulations are so you can eventually get your customers or asset owners the business objectives that they expect. And there is also an upside of being vertical specific, which is not necessarily something that is kind of like a risk. So until now, all we covered is what's going to happen to you if you're not going to use a solution that is fitted to the right industry, and what's going to happen to you if you're just going to use something that doesn't necessarily meet the particular requirement of a particular environment. But you can actually gather a broader business case, and that's something that I think the security industry neglects quite a lot, although it's probably an enabler to getting many of those solutions implemented in a large scale and getting the business buy-in within the industry. And the upside that you can see here is that cybersecurity data can actually serve operations. So some of the things that security solutions are doing and the methods that they operate, the data that they collect, is kind of on the cutting edge. Some of the anomaly detection that is being implemented, which is really based on the context of the network, which is really based on the activities that are happening in the systems, helps a lot of times to operations people. And I think it's being underestimated because of the different buying centers in the organizations. But in my opinion, moving forward, it's going to be quite important for security solutions to drive a lot of operational value as they evolve. And having this ability to actually drive additional revenue and save cost by implementing a security solution is something that can really get a broader buy-in and can really unlock a lot of opportunities for both improving the security as well as improving the business and operations in companies. So a way to think about it is you can think about the data that is being collected from the environment and the normalization process that we cross through the data. And whatever this thing can enable is quite huge. So you can think about enabling asset management processes, enabling configuration management processes, enabling the ability to generate operational alerts that can help for both maintenance purposes as well as preventive maintenance processes. And as we know that data is the future or the present of many of those companies, having the ability to normalize all this data and leverage it for both security and operational use cases really unlocks a lot of opportunities. And I'm not even talking about the ability to correlate this data and understand whether a functional alert is really a security alert or vice versa. This is also quite important because if you don't do that, you don't really get into the details of this particular system. But this is quite of an important illustration that I think all of us should have in mind when we're thinking about implementing security solutions in the different industries that we operate in. So my key takeaways for today are that industry context is essential to achieve precision. And precision is important because you can do a lot of things, but you should focus on what's important, and you should focus on actually generating value that can drive the business. And the other thing is that the opposite of not having this industry context is actually doing a lot of manual work. And it's something that you can't necessarily evaluate in the beginning, but it's something that is going to cost you a lot down the road. And this is it. Thank you very much. Okay. Yeah, please do. Hey there.
Can you give an example of operational value that's delivered through a cybersecurity solution in a vertical context?
Yeah, definitely. So for me, it's the easiest to speak about examples that in the industry that we operate is the rail environment. So just as an example, because of positive train control, railroads in the US have issues that trains are just stopping. Part of the way that our solutions are operating, we actually monitor wireless traffic in the rail environment. And with the context that we generate, for the purpose of generating security alerts, we want to identify things like evil twins and so on, we can actually help operators to investigate operational events which our trains are stopping, and it can be because they haven't received the right messages in the right timing or something similar to that. So eventually the business case that we have there is that there are some analysts that investigate different alerts, the operational events, and those analysts can actually work much less and investigate many more alerts, so it saves a lot in OpEx, and of course generates faster resolution to many of those incidents. Perfect, so thank you very much and enjoy the rest of the show. See you later.